Hey all. Our next talk comes from Tim Howard, and he will be talking about our journey from Ubuntu Server to Ubuntu Core.
Hello. So this is about my company, Everactive, and our journey from Ubuntu Server to Ubuntu Core. So I just want to say a quick thank you to Canonical for sponsoring me for the talk, otherwise I wouldn't be here, and Everactive for giving me the time to work on it and to travel to the summit. And it's also important that you know all opinions here expressed are my own. So I'm Tim Howard. I'm a senior staff engineer with Everactive. I've been there since January of 2018. I've worked there both as a Linux device engineer, a front-end and back-end engineer. I've been in professional software development for over 15 years, and I've used Ubuntu since the first release. You may also know me on the Snapcraft forums as Future Tim. I wish I could say that no devices were harmed in the making, but that's not true. Thankfully, this is actually not related to running Ubuntu Core, but it is one of our devices that I fried. So if you want to know more about that, you can ask me later. What if I could tell you, though, that I knew what the perfect solution was for how do you get your device to market, and it satisfied all your needs? Well, we all know I can't do that. But what I can do is tell you what I think is categorically the fastest way to get your device to market, and currently the best way to get a device to market that stays up to date automatically with very little intervention. And when it does require intervention, it's fairly easy to handle. And this is based on 2 years of development experience with Ubuntu Core and almost a year of deployed experience of devices. So our agenda today is to talk a little bit about where we started, what we did to evaluate some other solutions, or at least some things we considered, some of the features that led us to Ubuntu Core, which if you've been in some of the other presentations related to snaps or Ubuntu Core, they're going to sound very familiar, followed by some of the challenges or shortcomings related to Ubuntu Core and development around Ubuntu Core, the evolution of what we ended up calling device management service, and some final thoughts and questions and answers if there's time and there are questions. So here's a couple of pictures from some testing we were doing with some of our devices. These devices were pre-Ubuntu Core. I was testing them in a hotel in Times Square. We were sort of characterizing the performance of the LTE modem that we were using. Turns out that Times Square is a very noisy environment from an RF perspective, as you can imagine. So that provided some good testing. So when I joined Everactive in January 2018, Everactive is a startup focused on wireless and batteryless sensors. We were sort of just starting to deploy our gateways after some development. Our cloud strategy at the time was nascent, so the gateway was going to be asked to do a lot of sort of nebulous roles that we ended up discarding. At the time, we were using an x86-based box made by Dell. It's the Model 3001. So our primary gateway engineering team at the time, after I was hired, was 2 total. We mostly had, or almost exclusively had, engineering experience with classic Ubuntu, and so we were basing our distribution or our device on Ubuntu Server. Interestingly, though, the Dell 3001 at that time shipped, I believe by default, with Ubuntu Core 16. But instead, we were using a server image provided by Dell which was 1604. So at the time when I got hired, I had some basic knowledge around snaps just because I follow Linux development quite closely, so I at least knew they existed. So I took on the task of trying to snap our application stack. And so like I said, that was in 2018 when I got hired. I had some success doing that, but if you're familiar with snaps, you know there's a difference between confined snaps and unconfined snaps, running them under Ubuntu Core, running them on classic systems. And so it was kind of just too radical of a change at that time, and so we didn't pursue it further. We were also using something called SaltStack for our fleet management, which we weren't really sure how that was going to fit in with deploying Ubuntu Core, and so that was another part of the transition problem that we didn't really have an answer for at that time. Eventually we did, though, engage with Canonical in 2020, in September 2020 for Ubuntu Core, and at that time we had 650 gateways in the field running 1604, server 1604, sorry. So at that time, with a very small engineering team and a very small organization overall, especially considering what we, the scope of the things that we did, we had engineers actually taping out processors, all the way up to building an end-to-end cloud stack, as well as deploying all of these devices in the field. And at that time, I don't remember exactly, we were probably 50 or 60 employees. And so as you can imagine, trying to both develop applications for that device as well as managing and maintaining them was quite a burden. And so we were having trouble managing all of the updates, both for our applications and for the OS on those devices. A big pain point at that time was how we were delivering our applications. Essentially, we had two methods. We could either flash a device from scratch, like essentially a factory image, or we would deliver a tar archive remotely via SaltStack and essentially extract that on the device. And so as you can imagine, it was a workable solution, but it could lead to a lot of errors, a lot of problems, human errors. With SaltStack, you can directly manipulate files on the device, so occasionally we would have a device that had been manipulated previously, so when you extracted the application tar, things went wrong. The way we generated our production image at that time was essentially we had a reference device that had Ubuntu Server installed on it. We would set it up the way we wanted it, and then we would clone that, and that would be our production image. And again, you can see how that would be prone to a lot of human error. At that time, right around September of 2020, we were in the early stages of developing our next generation hardware platform called Apex for the gateways. So that meant we were going to soon be managing both the Dell 3001 and our new custom hardware. So we would need an OS for it. We would need a way to run the application stack that we had on it. And then we would have to, again, manage, maintain, update, and simultaneously develop our growing application stack for both targets. Lucky for us, we grew our engineering team by 50%. We added one person. So how did we get to Ubuntu Core? And what else did we look at? Well, so we knew that we wanted as full a control of our devices as possible. We didn't want anyone really in between us and the direct hardware. And preferably whatever we settled on would have a full fleet management solution. Unfortunately, Ubuntu Core doesn't have that, at least not technically. We'll see in a second why that's not quite true. But we tried to consider every possible solution, all the way from, building the OS from scratch, building out the infrastructure to deliver our applications and update them, to things like using Mender, if you're familiar with that. It's sort of in this space of, it offers an A/B boot so that if you fail an update, it can roll back. It delivers updates to your devices and your applications, but it itself is not an OS. So we talked about building our OS building the OS for our device based on FreeBSD. We considered resin.io, which I think is Balena Cloud now. So we tried to consider everything. And as I said, at the time we were only 3 people, so there were things that were immediately infeasible, like building it from scratch, but we wanted to make sure we at least considered all the options. So this is I believe this is a picture of me holding the first prototype of our Apex device, and it's booting Ubuntu Core. I think that was the first time it had ever booted Ubuntu Core. Yeah, again, so if you've been in any other sessions, all of these features are going to sound really familiar. We liked that the whole system was going to be snap-based, so from the kernel, the gadget, the applications, and it meant that the whole system from end to end had transactional updates. With Ubuntu Core, you also get nice fallback behavior, both for your applications and the kernel if things go wrong. We also liked, we haven't used it a ton, but we did like at the time that you could build snaps for both classic and Ubuntu Core systems. A lot of the devs at the time were running Ubuntu, so we liked the idea that you could build a snap for those classic systems as well. If you've ever built Ubuntu Core as a production device, it's unfortunate that the store won't allow you to deliver your snaps to classic systems. There's no way to enroll those or register them. But you could always build them on the side and install them that way. And again, so we were in the midst of rolling out, or at least starting to build our next generation hardware platform, Apex, and so the idea that we could build this snap for both targets, but it was one snap, was really appealing. Yeah, and so with our engagement with Canonical through Smart Start and later board enablement for our new hardware, we knew that kernel updates and OS updates were going to be tested by Canonical on our hardware as they were happening. So we were relieved of that burden. We also liked that if you built a snap, you pushed it to one place, and then depending on, of course, your schedule and what you wanted out of your devices, it could be delivered to both devices simultaneously with no effort from you other than pushing it to the store. And at the time, our applications, like I said, just ran on an Ubuntu server. We just extracted files directly on the file system, and you could have a dirty file system and things could go wrong. So when thinking about the architecture we wanted for our next generation of system, the idea of separating out all of our applications into individual snaps was really appealing because it forced us to do those things. And like I said, when we were building our applications, we knew that there were going to be some things for both targets that were different. But so we could extract a subset of the applications that made sense for both targets and share those across. It's the same exact snap on both targets. And then additionally, we could build a very small subset of snaps that might apply to one target or the other. So some of the additional features at the time that were either already available for Core or were on their way were over-the-air updates, secure boot, full disk encryption, which I think came later in Ubuntu Core 20, but that's what we're running on the Apex device. There's a built-in recovery mode. Additionally, initially we didn't realize this was going to be a capability, but we ended up having a partner that wanted to white label our device, And so we were able to offer them a sub-account brand store so that their device had only the snaps that we provided, either shared in common or customized for their device. So what were some of the challenges? Not all of these are directly related to Ubuntu Core, but they might be Ubuntu Core and related development. So there's a lot of things to really like about Ubuntu Core, but as they say, nothing's perfect. And if someone tells you that, they're lying to you. So firstly, one of the downsides is that running Ubuntu Core in production on custom hardware does require a brand store. And to have private snaps, you need a brand store. At least to run a device in this context, like having private snaps, having custom hardware, you need a brand store. And while Snapd and the associated parts are open source, it's tied to a specific store and a specific authority, and there's no way to add alternatives. So, not that you would necessarily want to run your own store, but if you did, you don't really have the option besides patching Snapd and running a custom Snapd, which is not totally unreasonable. But and so the store is not open source, and it's not just a philosophical question about whether the store should be open source or not. It's that it also prevents a lot of self-service. So in the development of our Ubuntu Core devices and applications, I answered a lot of questions for myself and the team just by reading Snapd source code, which is awesome. And if you haven't looked at the testing that goes into Snapd using Spread, you should definitely check that out because it's quite thorough. And so the store being a black box both prevents you from self-service, but it also prevents you from knowing exactly what's going on or how some of those pieces fit together once you're off device. So, the device makes a lot of requests to the store, but things happen behind the curtains in the store, and you don't really know some of those things that are going on. Also, for practical purposes, like I said, to have Ubuntu Core on custom hardware, you need intervention from Canonical. You essentially either need to engage their engineering team to do board enablement. Actually, I think that's the only way you can get it on custom hardware. And so your only other options for Ubuntu Core are to use existing target and the global public store. And so if those two things work for you, then Ubuntu Core is already a great choice. And the other thing about those limitations are that the community around Ubuntu Core in this context, running a production device, using a brand store, is almost non-existent. And so, one of the great things about running Ubuntu or using Ubuntu over the years is the community, and you lack that in this context. Again, if you're running Ubuntu Core on an existing target, using the global store, then there's a lot of people out there that can help you. Or just building a snap, there's a lot of people that can help you. But if you're running a production device in this specific context, there's not very many people that can help you. So one of the things as well that's sort of difficult when you're transitioning from a classic Ubuntu server or a classic Ubuntu system, which is not necessarily a negative, I think it's a net positive, but it does cause a lot of pain, is that all of the existing solutions that work on Ubuntu servers, say third parties for managing the device or monitoring the device, likely won't work. And if they work, they almost certainly won't work out of the box without modifications or heavy configuration. There's also no upgrade path from a classic system to a core system. Essentially, it requires a truck roll. So you have to put your hands on that machine to get Core on it. The tooling for building snaps and running an Ubuntu Core system, interacting with an Ubuntu Core system, and developing for an Ubuntu Core system need to improve a lot. They've improved a lot since the day we started, which was 2 years ago, but I think there's still a lot of work that could be done to help developers and make it easy. One of the downsides as well is that, and I understand from an earlier session we might be getting some relief in this area, but if you're developing with snaps, there's almost certainly a case where you will come in one day, a snap will have updated, and it will have broken your workflow. It's quite frustrating when you're under a deadline and have something to deliver, and now you have to fix your tools because they auto-updated. And you have no way to permanently hold, at least currently, permanently hold a specific version of a snap. It got so frustrating at some point I was using microcates, which is a fantastic distribution of Kubernetes in a snap version, but I eventually abandoned it because 2 or 3 times I would come in, it had auto-updated and had broken my Kubernetes setup. And I mention all of this, and you might ask yourself, why bother mentioning it? We engage canonical engineering. That's what they do. It's reasonable for a software company to want to get paid for the software they're designing and developing. But I've always been a firm believer that traction for products and market penetration is driven a lot by what an engineer can do at home or what an engineer can do with his community. And so if Ubuntu Core as a sort of private device on custom hardware is not readily available to an engineer at his house or for the communities he's in, he or she or they are in, then that's a limitation. And it's also a shame because I think Ubuntu Core is a fantastic evolution of the Linux system. It also lacks that idea of building software together as a community. So I'm running pretty low on time, I think. So I'll try to run through this really quickly. This is the evolution of what we ended up calling the device management services. Earlier I was talking about Ubuntu Core not having fleet management. That was sort of true and sort of not true. There was an open source project that Canonical had started a while back. It was a collection of services. I am not entirely sure of the story. I think they ended up not wanting to continue developing it, but left it available as an open source example of how you might build fleet management for Ubuntu Core devices. So we took it on and forked it. We eventually ended up consolidating all 3 services into one. Sorry about that. Yeah, so there it is at the bottom. So it's available on Everactive's organization page on GitHub. We ended up calling it DMS Core, which is all of the back-end services, and DMS Front, which is the front-end part. It used to exist as a collection of services called IoT Management, IoT Identity, and IoT Device Twin. If you're looking for the original source code, that's what it would be called. So it works by having an agent on the device that communicates with this service. Yeah, and so quickly, there are just some things that you would expect from the fleet management. You can change versions of snaps, you can change the tracks they're on, you can update them, you can set configuration for those snaps. All of that existed before we started working on it. Since then, we've added the ability to auto-register devices based on the signed key ID that's in your assertions. Assertions is sort of a way that the store delivers updates to your device and makes sure that they're permitted to do that. Assertions essentially are the verification of all sorts of aspects of Ubuntu Core. Probably too much to delve into here. We also started building a NATS-based Snapd API for our devices, since all of our applications talk over NATS. So NATS provided a way to have reasonable authentication and authorization, which is something you want, because if something has Snapd control, that application owns your device. We added some Terraform deployment configuration, Golang migrate for the databases. And so where are we at today? Let's see. Yeah, so we're currently shipping in production Ubuntu Core on both devices, the Dell 3001 and the Apex device. Our team is unfortunately back down to 2. However, we do have a dedicated network operations engineer who is fantastic. So he's responsible for sort of managing the health of our fleet. He uses device management service all the time. And we have approximately 340 gateways, not including partner gateways, running Ubuntu Core. So quickly, final thoughts. In my mind, there's no way we could have gotten our devices to market as capably as we did with such a small team without Ubuntu Core and canonical engineering services. For that, we are definitely very grateful. And it prevented our team from having to reinvent and re-implement the figurative will. Any questions? No time?
Yes, no time, unfortunately.
Okay. Well,